Good morning, students. Today we are going to discuss versatile nature of carbon. Many of things we use in daily life are made up of carbon compounds. We are also made up of carbon compounds, and the number of carbon compounds known today is approximately 3 million. Before we start study of carbon compounds, we must understand why carbon forms so many compounds. First reason is catenation. Carbon has unique property to form bonds with other carbon atoms. The property of forming bonds with atoms of same element is known as catenation, means self linkage property. And carbon has maximum tendency for self linkage in the periodic table. This is due to strong carbon carbon bonds. When carbon atoms combine with one another, they form different types of chains, such as they are arranged in straight chain, branched, or in rings. Now, in carbon and silicon have same valence electronic configuration, that is have 4 electron in the valence shell, that is outermost shell. Carbon atomic number 6, electronic configuration 2 4, 4 electrons in the outermost shell. Silicon with symbol Si, atomic number 14, electronic configuration 2 8 4, 4 electrons in outermost shell. But carbon shows catenation to greater extent than silicon. For example, carbon forms compound with hydrogen, in which hundreds of carbon atoms can be joined together. And the compound of carbon and hydrogen are known as hydrocarbons, and these compounds are very stable. But when silicon form compounds with hydrogen, contains chain only up to 7 to 8 silicon atom, and the compounds of silicon and hydrogens are known as silane, and these are very reactive. Now, the main reason for more catenation, more self linkage in carbon is its stronger carbon carbon bonds than silicon silicon bonds. Next reason is tetravalency of carbon. Tetra means 4, valency means combining capacity. Atomic number of carbon is 6. Its electronic configuration 2 4. The electrons present in outermost shell is 4 electron, and it means its combining capacity is 4, its valency is 4. Carbon forms 4 covalent bond in its compounds. Carbon has valency of 4. Its combining capacity 4. It is capable of bonding with 4 other atoms of carbon or atoms of some other monovalent element. Monovalent elements mean having valency 1. Now, bonds with carbon forms with the bonds that carbon forms with other elements are very strong. If these are bonds is very strong, it means the compound are very stable. The reason for the formation of strong bonds by carbon is its small size. It means nucleus hold the shared pair of electrons strongly. Next reason, tendency to form multiple bonds. Due to small size, carbon also forms multiple bonds, that is double and triple bonds with other carbon atoms, oxygen, sulfur and nitrogen. And this multiplicity of carbon-carbon, carbon-oxygen and carbon-nitrogen bonds increases the number of carbon compounds. As carbon-carbon form multiple bonds, if compounds containing single bonds between carbon atom, then it is known as saturated carbon. Carbon-carbon single bond. While compounds containing double or triple bonds between their carbon atoms. If there is double bond between the carbon atom or triple bond between the carbon atom, then compounds are known as unsaturated compounds. The unique characteristics feature of carbon, such as self-linkage, that is catenation, tetravalency, that is four-valency combining capacity, and tendency to form multiple bond, that is double or triple bond, give rise to large number of compounds known as organic compounds. Organic compounds are compounds of carbon and hydrogen, that is hydrocarbons and their derivative. It was believed that organic compounds cannot be prepared in the lab, but can only be isolated from animals and plants. On the basis of this belief that organic compounds cannot be prepared in the lab but can be isolated only from animals and plants, Berzelius proposed a theory that is vital force theory. According to Berzelius, organic compounds produced only under the influence of some mysterious force that exists only living organisms, that is plants and animals. And this force is known as vital force. And such a force cannot be created artificially. Means it cannot be created in the lab. It means it is not possible to prepare organic compounds in lab. But in 1828, Friedrich Wöhler made an interesting discovery. He accidentally prepared urea, a well-known organic compound that is isolated from urine of man and other mammals. He prepared urea by heating aqueous solution of two inorganic compounds, ammonium chloride and potassium cyanate. Ammonium chloride formula NH4Cl, ammonium chloride plus potassium cyanate, KCNO, undergo double displacement reaction. When we heat aqueous solution of two inorganic compound, that is ammonium chloride and potassium cyanate, then there is a double displacement reaction, positive, negative, positive, negative. It forms NH4CNO. NH4CNO, ammonium cyanate plus potassium chloride, that is KCl, potassium chloride, which on further heating, there is a rearrangement of atom. It forms organic compound urea, NH2CO, NH2. Actually, he was trying to prepare an inorganic compound that is ammonium cyanide. But when he analyzed the compound, it was found to be quite different. It was urea, formed by a rearrangement of atoms in ammonium cyanide. Now, molecular formula of ammonium cyanide: 2 nitrogen and 2, 4 hydrogen, 1 carbon and 1 oxygen. Same in urea, 2 nitrogen, 4 hydrogen, 1 carbon and 1 oxygen. There is only rearrangement of atoms on heating. It means no force was required in the formation of organic compounds in lab. First organic compound prepared in lab was urea. After the preparation of urea, acetic acid was prepared in 1845. After that, number of organic compounds were prepared in lab. Next topic is hydrocarbon. Compounds containing only carbon and hydrogen are known as hydrocarbons. Hydrocarbons are of two types: saturated hydrocarbon and unsaturated hydrocarbons. Saturated hydrocarbons are hydrocarbons which contain only single carbon-carbon covalent bonds. And unsaturated hydrocarbons, the hydrocarbons which contain one or more double or triple bonds between carbon atoms, are known as unsaturated hydrocarbons.